This is our last method to map out the location of electrons. This method is called orbital notation. The word orbital should sound familiar to you because it's part of the quantum address. Energy level, sublevel, orbital, spin. In this method, you show both the location in the orbital and you also show the spin, the positive and negative half spin electrons in those orbitals. So let's do the orbital notation for an atom of sulfur. How many electrons are in an atom of sulfur? As you well know, an atom has the same number of electrons as it has protons. And sulfur is number 16 on the periodic table, so it has 16 protons. So we're going to distribute 16 electrons. Things to notice when we're putting in these electrons: you always distribute the negative electron first before coming in and pairing the positive electron in that sublevel. If you take a look at your quantum address chart, which I know is really small here, but look at yours, you will see that the negative spin electron is the negative half of the spin is always first before the positive half spin. So this is hydrogen's electron. It's a negative spin electron. This is helium's electron. Remember, helium goes here on the chart. It's a positive half spin electron. This is lithium, beryllium, boron, carbon, nitrogen. Take a moment to look that boron, carbon, and nitrogen are all on the negative half side. They are all on the negative half side. They all have negative half spins. All the negative electrons are placed in the orbitals before coming back and pairing. This is oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, and finally sulfur. So that is the orbital notation for sulfur. How many half-filled orbitals will an atom of sulfur have? Well, this is easy to see with your illustration. You have two half-filled orbitals. Orbital notation for an ion of nitrogen. So how many electrons does an ion of nitrogen have? So an ion of nitrogen has 10 electrons because nitrogen's formula is an N-3. The -3 means it has 3 more electrons than it has protons, and it has 7 protons. So if it has 3 more electrons, it's going to have 10. Remember, they always have this number of electrons that is the same as their closest noble gas. So nitrogen's closest noble gas is neon, which has 10 electrons. So we're going to distribute 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How is this configuration any different than an oxygen's ion? Oxide. How is it any different than an O-2? It's not, because O-2 will also have 10 electrons. And elements, when they turn into ions, have the electron configuration of their closest noble gas. So here are some common electron configurations and their box notations. So the electron configuration for 1s2, 2s1 looks like this. 1s, 2 electrons in it. 2s, 1 electron in it. There's some more examples on this page. This is boron. Boron's electron configuration is 1s2, 2s2, 2p1. Its orbital notation for box notation is the 1s has 2, the 2s has 2, and the 2p has 1. It is simply an illustration of the electron configuration that you already know. So let's do the box notation for titanium. We'll need to distribute 22 electrons. So remember, you fill the negative electron first before filling the positive electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 electrons. If you'll look at the periodic table and you look where that is, you have put 2 electrons in the 3D sublevel. Look and see that titanium is 2 into the 3D sublevel. You fill the negative spin electrons before the positive spin electrons. This one is an example of an atom of fluorine. So remember 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a fluorine atom. You fill the negative spin electrons before you spin the positive spin electrons in each new sublevel. So they're going to do chlorine. They're doing an ion of chlorine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why is it 11? Sorry, it's giving other thing. It's going to have to get up to number 18. I'm up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It is number 17 on the periodic table, but it's got a -1 charge as an ion, so it has 18 electrons. This is what the box configuration for barium looks like. All right, so the box configuration is just like doing an electron configuration, except you're creating a picture for it. All right, that's all there is to it.